You are
How do you feel now?
geometry. I am not understanding. A few of them.
Yeah.
Like number 2 I was stuck on, but then then I got it, so that was fine. But number 4, I get it now. Number 6, I don't. Did I get why? Why that's 3? I just worked it out.
See, I missed when she was talking about it before, so I was like, why is this one?
Well, that's 120 because on a clock it's 20 minutes, and there's 3 20 minutes in a clock. So like if you say 360 divided by 3 is 120. That's how I thought of it. So that makes sense. And then the sides have to be 4. So then that makes this 2 and this 2. Well, and that's 120. So then that splits that angle in 2. So that's a 60, 90, 30.
This one was a kind of
Okay, so this is a semicircle because it says it's circle O. So like we know that this it's 120. This is 120. So the other part has to be 60 to make it half of a circle. So then you can find what that arc is, and then you can find all the angles because you have all the arc measurements. But that one took me a minute because I was like, where is she getting that?
Yeah.
Like, I'm like, I can't find any way to figure out what these arcs are, and I use those arcs to find the angles.
This one I got 200. I don't know how she's getting it sometimes.
Well,
Because I don't know how to draw it.
okay.
Because she doesn't like.
So P is not the center of the circle.
Yeah.
O is, because it's circle O. So then, like, that would be O. So, like, P would be somewhere up here. So it's not exactly. So that's not.
Yeah, I saw that she put on
How
there.
did
I
she
knew
get it?
it probably wasn't a big center circle, but she needs to specify.
So it's 200. So that's when you do 200 plus 40 times 1 because of this arc minus this arc, or plus this arc.
I'm on it now. I just did.
That's how you do it. 200 plus 40.
That's just
Yes, because I thought it was always subtracted. Fine. That's why I was confused. She said you can use that, right? Okay.
Yeah.
I don't know what mine is there.
Oh, they're all subtracting except this one.
The first one. Oh, I always look at this. That's probably why.
Well, these are the angles. These are the relationships of the segments.
I'm trying to figure this out. I need to be at least.
Like,
This.
yeah, that one drove me crazy.
I'm gonna try and do it. I guessed it first. I didn't get the second part. I got this part something.
I got 3. Well, because it was 2 plus that. So when you divide by 2, that cancels out. I remember you got a 1.
That's what the answers.
I don't think so. What number is that?
This.
No, it's just 2 root 3. There's no. Oh, there is a 1. How did she get that? I didn't get a 1.
I think I put here that 2 divides out,
Yeah.
but it's still a 1 here. But I don't know where I got this 2. Probably just.
Yeah, well, that makes sense. That's 3 times 16. 3 times 16 is 28.
4 squared is 3.
No, it's, so then 3 times 16. Right, but 4 square root 3. But then 2 divides 4 equals 2. 4 divides 2
Oh, it has to
equals 2.
discuss everything.
Yeah. Yeah. There is a 1.
Trying to think of my language is what confused. I'm not changing the letter names.
squared plus b squared equals c squared. That's what it is.
That's what we did on the last exercise. Well, I just put 6 equals 2x. I didn't make it. So it's 10 points.
I'm just nervous.
That would be, C instead of D.
I'm just nervous. Like, I feel like her practice exams are nothing like her exams, so the practice exam is going to help me.
I'm start off with these.
I'm going to do the ones I know, and hope for full credit on those, and then
Oops,
there's no proofs. Yeah, it's only this. It's only chapter 7.
No, she's here. Maybe proofs.
I don't think so. Did she say that?
It's in the,
I don't remember saying that.
in our stuff on here, there's a bunch of proofs in the I'm just going to go with that. I don't care.
Oh,
Trying to do like a linear function, so I don't understand.
A squared, B squared.
Finding the other ways. I have to like draw it out. Appreciate it.
Oh, yeah. I didn't get that. Like, I don't understand that at all. Like, I got 3. How did I get 3? Didn't get X.
From this coordinate. We do this as a number. So those are 2.
Equals 4 squared. Okay, so I got X equals 3, and then I had to find Y.
I'll try to coordinate this. Negative b squared plus or minus square root of e squared minus 4ac over 2.
Negative b squared plus or minus 2. I added.
I don't know.
B squared plus or minus, or no, B, here it is.
All right, Megan here,
B squared.
Elsa. Are we making a lot of students today?
You're right. Negative
I know
B
Aunt Elsa emailed me. Morgan here,
squared.
Okay.
Squared.
Allison,
Yeah, it's negative B plus or minus.
Katie
Here. 4AC.
Okay.
2A.
Leah, Catherine,
Here.
Curtis.
He's here. He just went to the restroom.
Okay,
Allie's walking in right now. Allison.
okay, Allison. Okay. All right. So today's probably it's gonna be. I think it's gonna be the last new lecture. Next Monday, I will answer your questions from the practice exam. Try to finish as many problems as possible. If you have some problems on the practice exam, you have trouble doing it, you can ask me next Monday. If you don't have any question, I probably will teach you something new, give a new lecture. But if you have a lot of questions, the class will be just devoted to answering your questions. And next Wednesday, as before, I will get your graded exam, practice exam back, and give you the correct solutions, and also, of course, answer your question. So I think our exam is on Wednesday, not the Monday, by the schedule. December 11th. So December 9th, there will be no class final week, and you come December 11th to take the final. The other thing is, Katie is here, right?
Yes.
I think I sent you an email a few weeks ago about one of the homework assignments. I forgot what was about it. It's either it doesn't open or something else. I forgot. It was a few weeks back. So,
Okay. Do you want me to just email you a picture of it?
Yes, that's
Okay.
my email.
Okay.
If you guys see search, if you can find my emails. If not, let me know.
Okay.
And there are some sort. Check your email if you receive anything. Sometimes I have trouble opening the file. Recently, I had trouble with Blackboard. I can't open the images on Blackboard, so I have to download them, and I try to open that way. If it still doesn't open, then I will have to email you to email me the homework. Okay. So this week, I will probably be sending out emails to you guys, and if any of the pictures after downloading I still cannot open them, I will just have to ask you to email me. Okay. All right. I'm not sure if it's the Blackboard system or whatever. Recent ones, homework 12, homework 13, I didn't have any problem, but 11, 10, and 9, I have trouble opening the images. Okay, so today we're gonna, there is a homework due today. Do you have any question about the homework due today? Yes. Number 6. Okay, so let me see. Number 6. 6.7. Oh, 6.7. Okay. Oh, okay. So if there's a negative in the problem, you will associate that negative sign together with the second term. For example, let's see. If you have 2x squared minus 3y to the third, that's to some power, whatever that is. So remember, the minus always goes with the next one. Okay, so this is like doing 2x squared plus negative 3y cubed. Okay, so when you apply the formula, and you will apply the formula to 2x squared and negative 3y cubed. Does that make sense? Okay. For example, I can go ahead and finish this one. So we have to save a little bit of time. Maybe let's change it to the third power instead of fifth. But the way to the question is going to be the same. So what we're going to do is we apply the formula, which says, remember how is the formula? 3 choose 0 times what? The first one to the what? Third, right? Okay. And the other one will be to the 0. You can omit writing this because anything raised to 0 will become a 1, right? So if you don't want to write that, it's fine. But to be consistent, it's like 3 to 0, third power, and then the other one will be 3. And then the next one will be what? Plus 3 choose 1. And this exponent will decrease by 1, which will be 2, right? Okay. And the next one, you will increase the power by 1, which is 1. Okay? And continue. Plus 3 choose 2. 2x squared to the first, and the other one to the second. Remember, when you add the exponents, they always have to add up to 3 because you have 3. When you do third power, it means you multiply 3 times. So you're going to have to choose exactly 1 for each pair of parentheses. So if you choose this one 3 times, you cannot choose that one. If you choose this one 2 times, you have to choose another one from the other parentheses. So that's why the exponents always add up to that exponent there. And plus the last one, 3. So there's a pattern, 3, 0, 3 choose 0, 3 choose 1, 3 choose 2, 3 choose 3. And then the exponent of the first one always goes down by 1 each time to 0. Again, if you don't want to write this term, because anything raised to 0, you get 1. If you don't want to write it, it's fine. And the other one goes up, 0, 1, 2, and 3. But continue to simplify it. using algebra. 3 choose 0. That's something you gotta memorize. What's 3 choose 0? Huh? 1. Yes. Okay. So 3 choose 0 is 1. It's not 0. Because if you have 3 people and you decided you're not going to choose anybody, that's considered as one method, okay, one way of selection. So that would be 1 times, I'm just going to work out maybe 2 of them. You can do the other one similarly. So 3 choose 0 is going to be equal to 1. Work out here. 1 times, and how do we do 2x squared to the third? How do we do that? Yes, that's right. That's one of the formulas in algebra. You can raise each one, if it's multiplication, you can raise each one to the third. So 2 to the third, that gives you 8. What's x squared to the third? X to 6. You power, you multiply powers. Okay. So that's the formula you learned in algebra class and calculus. In calculus 1, you also use that formula. And anything raised to 0 is 1. So that's the first part. And you can simplify it further. 1 times 8 is going to be 8, right? So it's going to be 8x to the 6. Now, I'm going to work out another one. You can do the other two. 3 choose 1 is equal to 3. And 2x squared and then square is going to be 4 times 4x to the 4th. Negative 3y to the third raised to the first. It's going to be negative 3y cubed. And simplify it. 3 times 4 is 12. 12 times negative 3. Negative, going to be negative. 12 times negative 36. And x fourth and y third. Okay. You do have to multiply all the numbers if you can. Okay. And continue to get the other ones. Okay. All right. Other questions?
This might be silly, but could you just kind of get me started on number 2 for 10.1?
Okay, sure.
I've got where then I find the Cartesian, like the pairs,
Mm-hmm.
and then I'm just stuck. I don't know how to figure out the A.
So, you say 10.1 number
2.
which one? Number 2? Okay. So the C is equal to 2, 3, 4, 5. D is equal to 3, 4. So question A, do you have trouble doing part A?
Yes, but probably just because I'm not sure what to do.
Okay. So is 2S, you can read it as related. Okay, S represents a relation. So is 2 related to 4? And this relation, how is this relation defined? You can go back to see, this is how the relation is defined. Okay, what does this mean? How does this relation define 2 numbers related? If you can call x, well, this is a different way to write two numbers related. If you remember, we mentioned, okay, so when in English we say, okay, x is related to y. Related to y by this relation, this relation s. By relation s. That's the long English sentence, right? So in math, we like to simplify the writing. So this is how we write it in math. So we put x related to y by relation s. You see that? That's how we write it. But there is another way to write it. What's the other way? You can write it as an ordered pair. X is related to y. See, what does this mean? X, y is in s, which means x is related to y by the relation s. So these are 2 different ways to write that English sentence. Okay? Is that clear?
Yeah.
So when you do this question, this is tell you x is related to y by this relation s. How? if x is greater than or equal to y. That's how we define they are related. Okay. So you may say, how could a relation be like that? Well, relation can be defined any way you like, not really like the relation we have, say, in real life, because, I know him, that's why we are related, or he's my relative, that's why we're related. It's not like that anymore. They can define it any way they like. So in this case, if your x, y bother you, you can think of x as first number and y as the second number. So if the first number is related to the second number, if and only if the first number is greater than or equal to the second number. We did the example we did. If you took notes last time, the example we did is less than, right? I think I did a less than. This we talked about a few examples. One of them is less than. We talked about marriage relation, friends relation, those three examples. Okay. So in this case, it's greater than or equal to. I can change the numbers a little bit. Let's say, for example, is 4 related to 4? Is the first number 4 related to the second number 4?
Yes.
Yes, because what? The first number is greater than or equal to the second number 4, right? So you would say yes. But if I ask you, is 5 related to the second number 4? Is 5 related to 4 by relationless?
Yes.
Yes?
Because it's greater.
Yeah. Be careful. You may say, well, 4 is less than 5. But you cannot switch the numbers. You make sure you have to follow the order. It says that's why the first number, second number is important. So only when you have the first number greater than or equal to the second number, x is the first, y is the second. That's when you can say the first number is related to the second. So in this case, 5 is the first number. 4 is the second number. So is 5 related to 4? Is the first number, in the other words, is the first number greater than or equal to the second number? Oh, I'm sorry. Yes. Okay. I was thinking less than. You're right. Okay. Sorry. Maybe I should switch it. Okay. What 4 is less than? Okay. What about 4 related to 5? No. That would be no. Yes. I was trying to find the example I did. I think I did less than before. And yeah. Okay. So this is the one I did. Less than. The second part. Okay, so this is how you check whether two numbers are related. Okay, make sense?
Yes, it does. Thank you.
Okay, so you will have to check every single one. For question A, you only need to check the ones they ask you. So they ask you, is 2 related to 4? That's all you have to do. And then for part A, there's another one that is 4 related to 3? And is 4 related to 4? Is 3 related to 2? So they ask you 4 questions. You answer each one. But for part B, you have to check every single one. So is 2 related to 3? Is 2 related to 4? And is 3 related to 3? Is 3 related to 4? Is 4 related to 3? Is 4 related to 4? And 4 related to 3? 5 related to 3? So you got to check all the 8 of them. And if they are related, so for part B, if you found out, you're going to find out all the related ones and then put in the parentheses. So for example, we didn't find out 4 related to 4, you're going to put it in there. We didn't find out 5 related to 4, you're going to put it in there. But 4 is not related to 5, so you're not going to put a 4 or 5 there and put all the ones related in there. Okay? All right? Other questions?
Do we have to explain after, like, why each one is, or no?
I wouldn't care too much about that. For this one, it's really easy, very obvious. So if you didn't explain because 4 is greater than or equal to 4, that's fine. For today's question, yes, you do. Today's homework, you do have to explain. Or for the other question, like in section 10.2, they ask you, is this symmetric, reflexive, or transitive. If you say no, you need to give a counterexample.
Okay.
If it's yes, probably all you have to say is to write down the definition. Okay. So for this one, if you say, okay, if I didn't explain, it's fine. So not a big deal. Other questions?
Listen.
No? Okay, now, last time, in one of the homework questions, let me show you, can you see my computer screen? Yes? Okay. All right, so let's look at homework 10. So last time, I also asked you to do number 2 from section number 2, 4, 5, 7, 8 to answer all of these A, B, C, D questions. So I give you examples to do B, C, D, and I also talk about the directed graph, but I didn't have time to give you too much detail. So if you have trouble drawing a graph, and you can finish that after the class. I did give a quick example last time, so let's go back to our example. So last Wednesday, when I discussed whether it's reflexive, symmetric, or transitive, I didn't really use any graph. So if you want to use graph, that's a different way to help you check whether it's reflexive, symmetric, and transitive. So it's a different way. You don't have to do this way, but it just gives you a different option. So some students may find this way easier. So I'm going to go back to the example we talked about last time. Let me write down the question. It was on page 585. So we already covered that example. So you should, if you were here, you took notes, you don't have to copy this down again because we already talked about this. So R is equal to 0001, 03.
We're still on the computer.
Oh, sorry, thank you. So we discussed these three relations, R, S, and T, and whether each one is reflexive, symmetric, transitive, by using the definition. So now I'm going to show you a different way to do it. Okay, so we draw what we call a directed graph. So what we do is, for the numbers given, 0, 1, 2, 3, for each number we draw a point, 0, 1, 2, 3. How you put the points, it's really up to you. Sometimes maybe you want to move them around, so lines are not too much crossed, but right now, at the beginning, I'm just going to randomly put them here. Let's look at relation R. How do we draw the graph? So this means, what does 0, 0 mean? 0 is related to 0, right? So if you found a pair in there, 0, 0, you are going to draw a line segment from first number to the second number. For 0, 0, 1, it's easy, so I'm just going to draw a line segment starting from 0 to 1, and directed graph, there's a direction. The arrow should point toward the second number. But what about 0, 0? Because the first number is 0, second is 0. So you're just going to draw like a loop, starting from 0, go around, and then come back to 0. So you're going to see something like that. And so I draw 0, 2, 0, 1, and then 0, 3, starting from 0 and at a point toward 3. 1, 0. That means you're going to start from 1 and go back to 0. I already have a line segment here. I don't need to draw a new line segment, but I'm going to add an arrow point toward 0. See what I did? So this arrow means 0 is related to 1. The second arrow means 1 is related to 0. Okay, is that clear? Huh? Oh, if you draw a new line, yeah, that's fine. Oh, I guess the textbook did draw a new line, huh? Okay. So you can do what textbook did. They draw a new line. They draw another line like this. Okay. So they will have. Yeah, both are okay. So you could draw one line point to this direction and the second line to that direction. Or you can use the same line, just with two arrows. Now, and then next one will be, I did this, I did this, I did this, I did this. The next one will be 1 to 1, so you do that. 2 to 2, do that. 3 to 0, 3 to 0. So we can follow the textbook, draw another line segment and go back. And 3 to 3, 3, go back to 3. But this will be the graph, directed graph to describe this relation. So now you don't have to look at that anymore. Just look at the graph. Every loop here, every circle here tells you what? A number is related to the self, right? And which is the definition of which one is checking the number in itself out of those three properties. Reflexive, right? So we have reflexive, we have symmetric, and we have transitive. But if you have a loop at every number, that tells you it must be reflexive. So by looking at the graph, I have close the circle at every number, so that's reflexive. And if you don't do the graph, the way we did it before on last Wednesday, we found, okay, 0, 0 is in there, 1, 1 is in there, 2, 2 is in there, 3, 3 is in there. That tells me it's reflexive. But by looking at the graph, it's maybe a little quicker. Now, how is symmetric defined? How is the symmetry defined? If you have 0 related to 1, then 1 must be related to 0. In general, we say if your first number is related to the second, you must have the second number also related to the first. So what we did before, we say if I have 0, 1, then we must have 1, 0. After we switch, then it must be there. If we have 0, 3, 3, 0 must be there. Well, that's all we have. Then that's why we say it's reflexive. But looking at the graph, how do we tell? 2 lines. If you have this, 0 related to 1, then you can go back. If you have 0 related to 3, then you can go back. 3 is related to 0. So every line segment you see, not those loops, and it has to be double lines. Okay, so that's symmetric by looking at the graph. But if you don't have, so pretty much means you cannot have a single line segment like this. If you have a line like this, line segment, without going back, that means it does not meet the symmetric property, right? Now, transitive is a little sort of complicated. Even if when we did it by definition, it's a little complicated. And you have to see, okay, 0 is related to 1. That's the first number. That's the second number. And then we have to find something to continue. Is 1 related to 0? Yes, is 1 related to something else? We find out 1 is related to 0. So that would be the second related to the third. And we want to make sure 0, 0, first is related to the third, which we do have it in there. So that's why we have to check every single one, right? So what does this mean for the graph? How do we check? The graph would be like this. If x is related to y, and y is related to z, drawing a graph, what must we have? X is related to z. So you're going to form a triangle like this. X related to y, x, y related to z, you have a triangle x related to z. So that's what you will be looking for. So we have x related to y, but 1 only goes back there, so which means the first and the third, you don't really form a triangle anymore. It's like you have to go back to the south. And so in this case, and the same thing here, 0 is related to 3, and 3 goes back, so 0 related to 0. And so sometimes you may not be able to find a triangle. It is transitive. So that's why I'm saying the third one is the most difficult one to check. Either do it by definition or do it by looking at the graph. I can do the other two. Well, before I do the other two, do you have any questions about the graph?
Can you explain it? So it's x goes to y, y goes to z, and x goes to z?
Yes, okay. So like you normally you should have perfect situation, you will have something like that. But the problem is this z doesn't have to be a new z. Z could be the same as x. So draw the graph again if this line is the same as that. See what you're going to get. Can you draw the graph? So x is related to y. But this z doesn't have to be a new point. This z could be the same as x. If I move this z, identify x and z, what do I get? Can you see what the graph looks like? Z and x could be the same. They don't have to be different. If they're different for a triangle, if they're the same, look, let me move this z, slide it back to x. Now this line segment will become what? So x is the same as z now. Will be like that, right?
Yeah.
Okay, because y to z, right? So y to z. And then there was a line from x to z. But x and z are the same point now. What will this line segment become?
Loop.
A loop, yes. So it's going to look like this, okay?
I was just confused because when we wrote them down the other day, I thought we said R wasn't transitive.
Okay, let's see if there's, for R is not transitive, let me double check.
I thought that's what we said the other day.
What was the reason for, what was our explanation for it's not transitive? Let me check. Oh yeah, it is not. Okay, so I haven't checked everything yet. I'm sorry. Okay, so let's check. So I did check this one. It is, fits the definition. Now let's check the other one. So we have, I checked the 0 to 1, and then 1 to 0, then we have 0 to back. And let's go check it backwards. We have 1 to 0, and then 0 to 0 and 0 to 1. Then I should have 1, 1, which also works. And then we have to have, these are the two, the ones doesn't work. Look, let me draw another one because it's a little too hard to see now. So this, which one doesn't work is, so drawing the graph, even drawing the graph to do the third one, it may not make it much easier than doing it by definition. Okay? So I'm going to use a different color to show which one doesn't work. Now, do you see that there is a one go like this? Okay, so this is like that. So you can think of this as x, first number related to second y, and there's continuing doing that. So if you have this and that, you should form a triangle. You must have, so this is the first number, and this is the second. First related to second, second related to third. You must have first related to third, so you must have this line segment there, right?
Gotcha.
But we don't have 1, 2, 3. There's not a line segment there. So this violates the transitive property. Okay. Well, so if you see any line segment that goes like this, but you cannot form a triangle, that will not be transitive. I should have marked that out. Any other question? And so I'm going to draw another one for S. Let's see. So 0, 1, 2, 3. What we have is from 0 to 0, it's a loop, and 0 to 1, 0 to 3, 2 to 3. Okay, that's all we have, right? Now let's check. Is this reflexive? Reflexive, you must have the loop at every number, every point, right? We only have one loop here. The others don't. So it's not reflexive. So it's not reflexive. Is it symmetric? Remember what we say, how do we tell whether it's symmetric? By looking at the graph. If you always have, you don't have a single line segment. You always have two, it's like you cannot have a one-way road, okay? Just like in real life, you drive, there's a one-way road. Every road every street should be two-way, okay? So like going this, going back, going this, going back. If you have something like this, not going back, then one-way road, then it's not. So in this case, we look, do we have one-way road. A bunch of them, right? This one is one way. You have a line goes from 0 to 1, 2, but you cannot go back. And there's another one, there's another one. So it's not symmetric. What about transitive? If you have, it goes from here to here and here to here, you must have first related to the third, right? Looks like it meets that relation. So it is transitive. Now the third one, we can do the last one real quick, maybe just over here. So this one only has two relations. So 0, 1, 2, 3. We got from 0 to 1, 2 to 3. Okay, is it reflexive? No, we don't have any loop at all, right? So is it symmetric? Now we saw two one-way street. That's not symmetric. Symmetrically, you must have every street has to be two ways. And then is it transitive? Transitive is the tricky one. Is it transitive? It is transitive. Why? Because what we said before is if you have first number related to the second and second is related to the third, we must guarantee first is related to the third. So this red line is based on these two black line segments. If you have these two, you must have the red one. But if you don't have these two, you don't have to have the third one. So when we look at this relation, we would consider it as transitive because we don't even have these two joined black line segments. See, we have 0 to 1, but I don't have one pointing towards another one. You cannot continue. That means I don't have to have that third line either. The same thing. Here we have 2 related to 3, but we don't have 3 related to anything else. So that would be considered as a transitive. The transitive, it just says, if we go back to look at the relation R, that it's not transitive because you have 2 joined line segments, but you don't have the third one to form a triangle. If you only have one line, you don't have to form a triangle. And the second one, we exactly have a triangle. Okay, so different situations. All right, so when you do those questions, when you take the exam, if you want to do it by drawing the directed graphs to do it, you can. If you're just going to go by the definition, it will also work. So it's really just gives us a different tool to do the type of question. Okay, but this way is really limited. You can only do this way for finitely many relations. If you have many, it's not going to be very easy for us to draw the graph. So if you have infinite many points, how are you going to draw infinite many points? You can't, right? So that this way only works for this type of question, when you have all the relations listed. So today, any other question? Okay. So today we're going to continue to look at, I'm going to give you more examples in 10.2 to help you do number 16 and 19. See, like I said last time, last Wednesday, one type of question is, like what we just did, every relation is listed. See, this second relation is all listed. Fourth relation is all listed, and so on. Well, what if it's not listed, like number 16 and 19? All we are given is just one sentence. Just like the example asked at the beginning, like number 2. They did not list everything for you, right? You have to figure out which ones are, which order pairs should be in the relation. So number 16. And 16 is even more difficult than number 2 on this last week's homework. This number 2, you only have these many numbers. At most, you check 8 times, you get all of them. But number 16, how many numbers are we supposed to check? What are these numbers from? Where are these numbers from? Does everybody remember what this Z stand for? Integer number set, right? So what does this mean? M is a integer. N is also integer. So M represents the first number. N represents the second number. How many integers do we have? How many integers are there?
Infinite.
Infinitely many. 0, 1, or -1, 2, or -2, 3, or -2, 3. So there are infinitely many of them. So are we able to list all of them?
No.
If you think about, you can do that. Yes. So 0, we have 0, 1, 2, 3, all of them go on forever. And you can go down to -3 and it's go on forever. Let's write down 2 of them. -3, -2, -1, 0, 1, 2, 3. But if you try to do the same way we did it before, okay, you have to do 0, 0, 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, and infinite many of them. And you also have negatives. And then after you're done with 0, then you got to check 1 with every single one down here. Infinite many of them. You got to check 2 with every single down here. So it's impossible to do that way anymore. And the graph, you cannot draw a graph either. So we have to go by definition. Okay, so I'm going to give you, last time I did give you an example. If you remember, one of the relations we did it before, x is related to y if and only if x minus y is even. Do you remember that example?
Yeah.
Okay, so let's take a look at that relation again. Okay. Yeah, so this is the 2 examples I went over last Wednesday. The first one was x minus y is even. But what's the other way? Can you think of another way to describe x minus y is even? So when I say x is related to y, I mean x minus y is even. What's the other way to describe an even number?
2K.
2k, or 2 divides x minus y, right? Okay, x minus y. So the other way to write it is 2 divides x minus y. Right? If you can write x minus y as 2k, which means x minus y is divisible by 2, or 2 divides x minus y. So that's the other way. And then compare it to the homework question. Same thing. I mean, not exactly the same. The difference is I have 5 divides m minus n instead of 2 divides m minus n, right? Okay. And I use the x, y, and the homework used the m minus n. So I can change this problem to a similar way. Maybe today I can do 3 divides instead of 2. So last time, if you took notes, we already did this before. How do you check? Do you remember how do we check whether this is reflexive? How do we check it? If we don't use this way, just use that. How do we check it? Why is reflexive? Because, yes, that's right. Any number x minus itself is equal to 0, which is even, right? But if they give you that form, which means all you have to put is 2 divides x minus x. Why? Because 2 divides 0. Any number divides 0. So that's the other way to put it. And how do we do symmetric then? Because if 2 divides x minus y, then 2 divides y minus x when you switch them, right? But let me rewrite it in a different way. So previously, when we did this question, how do you check whether it's reflexive? We said because x minus x equals 0 is even. Which means, what does this tell us? It tells us x is related to x. And how do we check it's symmetric? Because we proved if x minus y is even, then y minus x is also even. So that tells us it's symmetric. In other words, x related to y implies y related to x. That's symmetric. And transitive, again, if you took notes last time, you don't have to copy this down because it's exactly the same thing. I did that last class, so I'm just repeating it. if x minus y is even and y minus z is even, then x minus z is even. And we also proved this. So this tells us x related to y and y related to z. Y related to z implies x related to z. So these are the three ones I did. If you look, that's my notes from last time. So if x minus y is even, then y minus x is even. And we actually proved it. And also we proved the third one. So if they change the question to the relation, the way to write it, instead of saying x minus y is even, they could say if and only if 2 divides x minus y. Well, you can change the way you say it here. So you can say because 2 divides x minus x. And over here, what do you say? If 2 divides x minus y, then 2 divides y minus x. And the same thing here. If 2 divides x minus y, and 2 divides y minus z, then we have the conclusion 2 divides x minus z. Okay, my 2 probably is kind of like a z now. It's a 2 and a z. Maybe I put a line through z so you can tell it's z, not 2. Okay, so that's all you have to do. So I am going to do another example similar to that one. So instead of doing through 2, the homework is 5, right? So the homework is 5. So I can do 3. Do another one here to help you. But pretty much the way is exactly the same. Maybe to make it easier, I'm just going to modify here. So if you have a relation defined as x related to y, this is the relation defined. X is related to y if and only if 3 divides x minus y. So when I check reflexive, I have by the definition, x has to be related to itself. Or graphically, it's a loop, right? So I'm going to have to prove not these anymore, not these anymore, and not these anymore, not these, the one in red. So I need to show 3 divides x minus x. Does 3 divide x minus x? Yes, why? Because x minus x is 0, right? So because 3 divides 0. It's the same as 3 divides 0. Now, change that 2 to 3. If 3 divides x minus y, then 3 also divides y minus x. Is that true? Yes, think about it. What is a quick way? You can do it by definition like I did last time. X minus y. If 3 divides x minus y, how do you write x minus y? How do you write x minus y? Equals 3k, right? And how do you prove y minus x is also 3 times the integer? Multiply both sides by -1. So you're going to get 3 times negative k, right? So that's the proof. But if you just want to explain in sentences, say something like, well, because y minus x is the opposite of x minus y. If x minus y is multiple of 3, then the opposite must be a multiple of 3. Okay. Or if you don't want to use sentences, this is how you do it. If x minus y is equal to 3k, then y minus x equals 3 times negative k, which tells us 3 goes into y minus x. Questions? Now let's do transitive. So transitive, I have to change all of the 2's to 3. So that would be a 3, that would be a 3, that would be a 3, right? So let's see how we prove this. It's the same as what we did last time. So the third one, you do have to prove it. Because it's not a very straightforward. If you ask anybody, well, it's not, most people cannot tell whether this is true or why this is true. So we need to prove if 3 divides x minus y and 3 divides y minus z, then 3 divides x minus z. How do we prove that? Go by definition. So if we know 3 divides x minus y. What does this mean? Rewrite x minus y by the definition of divisibility. What's the definition of divisibility?
X minus y is divisible by 3.
Yes, how do you write it in symbolic form? Instead of sentence, equals what?
Equals 3. 3 times an integer.
Yes, that's right. 3 times the integer, we can use k. Okay, right? Do you all remember that definition? Okay. Now, similarly, we also know 3 divides y minus z. So what can we get from that one? Y minus z equals what?
3 times L.
Very good. Make sure you use a different letter. Okay, how do I prove x minus z is also equal to 3 times integer? By looking at these two. How do you come up with x minus z? Huh? Add them. Okay, so one way you can do is add them. James said we can add both sides. I know, Curtis, in the past, you like to do substitution. You can also do substitution. Solve for y in the first one and plug it into the second one. Or solve for y in the second one, plug it into the first one. Either way is fine. Or maybe the quickest way is to just to add. So what is x minus y plus y minus z? X minus z, right? Because negative y cancels positive y. You're going to get x minus z. And on the right-hand side, you're going to get 3k plus 3l. Is 3k plus 3l a multiple of 3? 3k plus 3l, is that a multiple of 3?
Yes, because you can pull out the 3.
Yes, exactly. So that's just factor out of 3. So what does this tell us? 3 divides x minus z, right? So 3 divides x minus z. 3 divides x minus z. So we proved, if you tell me 3 divides x minus y and 3 divides y minus z, I can prove 3 divides x minus z. So that's the proof. And we learned how to do that before the second exam, divisibility. It's actually very easy practice problem on divisibility. Okay, so this is, do you have any questions? That should help you. When you have in the homework, there's a 5 there, right? So you pretty much you do exactly the same way, okay? Change that 3 to a 5. That should work. Now, the second one is absolute value. I think I might just let you try the second one. See if there's a, because I can give you some hint what to do. So, for absolute value, if the first number x is related to the second number y, if the first number's absolute value is equal to the second number's absolute value, that's why you need to. So how do we know if it's reflexive? What do we have to check? Okay, so let me write this down here. So the first number, instead of using x and y, I'm going to use the first number and the second number. This is how the relation is defined. The first number is related to the second number by relation A if the first number's absolute value is equal to the second number's absolute value. Well, for reflexive property, what do you do? What do you check? What do you plug in? The first number will be x. The second number will also be x, right? Okay. So you just need to check, is the absolute value of x equal to x absolute value of x, okay? What about symmetric? What do we need to check? Suppose the first number's absolute value is equal to the second number's absolute value. Can you prove? Switch them. Second number's absolute value is also equal to the first number's absolute value. Right? Okay? Now, transitive, what do we check? Transitive, you have 3 numbers. So this is just first number and first number. That's you need to check. Usually we use the letters x and x. Second, symmetric, if the first is related to the second, can you prove second is related to the third? Sorry, not second, third, first. Transitive, you have three numbers. First related to the second, and the second is related to the third. Can you prove first related to the third? In this case, what does first number related to the second number mean? What does this mean? What does the first number related to the second number mean? If the first number's absolute value equals second number's absolute value. Okay, so this tells you the first number's absolute value equals the second number's absolute value. And what does this mean? What does this tell us?
Value is equal to the third number's absolute value.
Yes, that's right. Combining these two, can you prove that first number's absolute value equals third number's absolute value? Right? Okay. I mean, it's very obvious. You probably don't really need much proof. You can just write, well, if you think it's, yes, it would be true, then you can just write down, okay, if this absolute value equals that, then that second equals third, then the first equals the third. So that's all you have to say. Okay? All right. Now we can move on to last section. Number 17, we already talked about last week. I'm sorry, this is not the number 17. Yeah, under 10.3, the problem I need to go over is point 6. 17, part A, we already talked about that. The major relation. So something new for this section is to found the equivalence classes. Okay, so here I'm going to give you an idea. So 10.2 is talking about something called 10.3, sorry, not 10.3. Equivalence classes. Equivalence relation. I mentioned this name before. Anybody remember what kind of relation is an equivalence relation? Does anybody remember? When we talked about 10.2, I mentioned that name. Anybody remember? If a relation is reflexive, symmetric, and transitive, then we call that relation equivalence relation. Okay? All right, so if you have equivalence relation, it has a very good property. So I'm going to go back to the real, let me think. Let me give you a kind of like a real life example. Suppose we have students here in our class. I'm going to kind of use a name. Say, suppose James, Elena, and Curtis, Morgan, and Katie. Okay, so let's say James is middle childhood education. Elena is, say, early childhood education. And Curtis, middle childhood education. And Morgan, middle childhood education. And Katie, let's say she's a math major. Okay, so, well, let me maybe add one more, sorry. Let me add one more so to make it a little different. Start with the, what else do we have? Want to start with a different first name. Maybe CP. Well, let's just create say, Danny. Danny is also early childhood education. Okay, so we talked about this before, major relation. It is reflexive, symmetric, transitive. Because, so if you think about it, why is the major relation? First student is related to the second if and only if X has the same major as Y. Has the same major as Y. So that's the homework question. So why is this equivalence relation, why is it reflexive? Can you explain in one sentence? Why is this major relation reflexive? Because everybody has the same major as yourself, right? Okay, that's reflexive. Why is this symmetric? Yes, that's right. If you have the same major as somebody else, that somebody else must have the same major as you, right? That's called symmetric. You switch them. Why is this transitive? 3 people, right? If the first student has the same major as the second student, and the second student has the same major as the third, you can guarantee the first student must have the same major as the third, right? Is that right? That's very, very intuitive. So you can, that's the homework question. You do have to prove this. How do you write on the proof? Pretty much what we just said, okay? Just write on sentences, okay? So now, after that, this is the same as the first type of question to prove why it is reflexive, symmetric, and transitive. It's going to be the same as you did before. But what's new is what we call the equivalence class. So what is the equivalence class? The main idea is you put all the students who are related to each other in one class. We don't call it a group, we call it one class, okay? So, look at their majors. Who will be in the same class? Well, okay, so Katie will be in the class by herself because she's the only math major, right? And, okay, that's Katie's class. Katie is not related to anybody else, right? So how is the relation defined? If Katie has the same major as somebody else, then Katie is related to that student. But, well, Katie is the only math major. She's not related to anybody else. So she's going to be by herself in the class. And what about other ones? We have so you do
C and F.
C and J, C, M, right? They will be in the same class because they all have what? Middle childhood education major. And what else?
E and D.
Yes, they are early childhood education major, so they will be in the same class. And because they are related. I mean, this one is very intuitive. You can just look at the majors. Okay, middle childhood, middle childhood. So they should be in the same class. And early childhood education, they're going to be in the same class. But later when you do the homework, they may not be as intuitive as this. So in general, I'm going to show the way how you're supposed to do the question. So in general, you are going to start with one of the students, anybody. I wouldn't just pick the students randomly. I'm going to start with the first one. So I'm going to start with James. I'm going to write down James and try to find out all the other students who are related to James. So what do you mean related to James? If they have the same major, right? So I check E, I write down James, and I check it. Elena, she's not related to James because they don't have the same major. But Curtis is related to James because he also has the same major. And Morgan is related to James because he has the major. So, and then Katie is not, and Danny's not. And I went through everybody else. I found out that's all I can find. And I'm going to cross them out from the list so I don't have to check them again. So I don't do redundant work. So I found out James, Curtis, and Morgan, they are all related to each other. They should be in the same class. And then I'm going to start with the rest of the students, Elena, Katie, and say Danny. So I'm going to start with Elena. And I'm going to check Katie. Well, she's not related to Elena. And Danny, yes, he is related to Elena. And that's all. So I'm going to mark them out. And then I only have a Katie left. I'm going to I write down Katie and try to find out if anybody else is related to Katie. But everybody's out. We don't have anybody. So that would be just the Katie by herself. Okay? I think I'm going to do one more example. What if you don't really have a real life situation? You're just going to have, say, some numbers and a relation defined. Maybe two examples. So homework is number 4, so I can do number 3. So number 3, it says A0 0, 1, 2, 3, 4. So these are the 5 numbers we're discussing, just like those 5 students, 6 students we have. And the relation defined is this: 0, 0, 0, 4, 1, 1, 1, 3, and 2, 2, 3, 1, 3, 3, 4, 0, and 4, 4. Okay, so their question already told us this is an equivalence relation, which means it is reflexive, symmetric, and transitive. They did not ask us to do that. They told us this is an equivalence relation. So by the way, you can only do equivalence classes for an equivalence relation. If it's not equivalence relation, you cannot do equivalence classes. So the question is asking for equivalence classes. And after being told it is an equivalence relation, I'm going to start. So remember what we did? You just randomly pick a number, but usually let's start with the first one, 0. So I'm going to start with 0, see what numbers are related to 0. Can you tell by the relation which numbers are related to 0? Four is related to 0, right? Is there any number else related to 0? No, that's it. That's the only one. So you're going to cross out 0 and 4. They are related. So they should belong to the same class. Now I'm going to, from the rest of the numbers, I'm going to pick 1. Okay, what numbers are related to 1? That's it, right? There's no others with 1. And 1, of course, but 1 is already there. So I put 1, 2. So these 2 are out. Now I'm going to start with 2. Well, that's the only one left, right? Pretty much you don't have to check. Oh, there's a 4. Oh, I already have 4. Okay. So that's everything. After you finish your equivalence classes, every number should be in there. You cannot miss any of them. So I did a 2, every number. So that we have 3 classes. The first class has 0, 2, second has 1, 3, and third one has a 2. So 3 classes. Okay. Now, what about I can do the other relation. What if it's not listed? So the next question, next type of question is going to be like this, the one we defined before. I can use the same number like the homework. So we have these numbers, 9 numbers, 10 numbers, 11 numbers given, 3, 4, 5. So these are numbers given. And x is related to y if and only if x minus y is even. So how do I find all the equivalence classes? What do I do first? Start with one of the numbers, right? So usually you just start with the first one. So I'm going to start with -4. And can you tell me what numbers are related to -4? -2, 0, 2, and 4. How did you know that? We talked about this before, right? So you have to check whether -4 minus that number is even. Well, why -3 is not in there? Because -4 minus -3 gives you a -1, which is not even. It's odd, right? So we know, okay, -3 shouldn't be there. But -4 minus -2, it's -2, which is even. So -2 should be there. And -4 minus 0, it's -4, that should be even. And -4 minus 2, it's also even. -6 is even. -4 minus 4, it's -8, which is even. So that's all we found. And the other ones shouldn't work. So let's cross out all these ones we have. So let's start with the rest of them, -3. I pick -3, and then -3 minus -1, it's -2, which is even. And -1, it's also even, -4, -3, and -5. So that's everybody else. And we know what kind of numbers minus, if x is even, say when you start with -4, an even number minus what kind of number will be even? Has to be even, right? So even if you didn't check every single one, you should know all the evens should be together, all the odds should be together. if you start with -3, -3 has to subtract the odd one in order to get it even. Okay. So yeah, that's how we do this type. Okay. So if you look at the homework question, one of them they listed every single one, and the other one they didn't list it, but you have to check. Say if I start with -4, -4 minus which number will be a multiple of 3. So you have to check every single one of them. So for example, -4 minus -1 is -3, which is divisible by 3. So -4, -1 should be there, and then you should keep looking for the number. Okay. So the homework question will be similar. Number 6 will be similar to this example that I just did. Okay. A little harder, but it should be the way to do that. It should be the same. Okay. Any question about this? No? Okay. Tom, anybody has a question? So if not, well, I'm going to need you to, I'm afraid next week, if you have a lot of questions, I won't be able to have time to do the evaluation. So today, since we have 10 minutes, and I'm going to ask you to do the evaluation. So your operator should have the evaluation package ready there. Somebody has to probably, I don't know, take the lead and
Oh, wow.
Waited for the winner to do it.
Okay. So, on the central sheet, it's gonna ask for a 5-digit class number.
I didn't see her say. Usually she would say.
511.
I was thinking,
This semester, what?
Yes.
The campus is 0 to 4.
Yes. And you have to double in on this on the other concession, right?
Yeah.
What's this?
So you can have the class code. All right. We can just hand that to you. You said why? I just lied, period. Okay.
Wait, what's campus code?
000. FAO. invited me to do this like rock thing. This is real. She invited me to do this like rock thing. It's like a women's empowerment club or something.
Oh, cute.
And it's like 3 hours, and I do over and pictures of girls. So like 3 hours, something super cute and fun for like my hours that I need, and I'm like kind of relying on it because the original exam schedule, like I said, right, we were supposed to have this exam in our 4200 exam on Monday, and then they changed it, and then they just sent out like a
they
new
did?
format and everything.
Oh, wait, what?
So that because at the beginning of class, when Michelle was like, "Oh, we're having it on Wednesday," I'm like, "We are," and then I looked it up, and they changed it. Or maybe I was just looking at the wrong place in general, but like I just typed in like Ohio University Lancaster qualified and exam schedule, and I think that they just hadn't refreshed it from last year, and so they changed it for this year.
Okay, well that's BS.
I know.
Like you can't just.
So when is this
final
4200 on Wednesday or
Or
Monday?
it's on Wednesday, and this one's on Wednesday too.
Oh,
And so, and it's like, it's right at, because I remember specifically when she asked me like a month ago if I could do this. I was like, I think I can, and I looked it up. And they didn't say anything yet.
So we are presenting Wednesday before.
If you're cool with that.
I'm fine with getting them on.
Me too. And so I emailed them, I hope he emailed me that. But, I know that's not. But.
So then it's 3,000 on Tuesday or Thursday?
Our math records?
That's
Or no?
no.
So annoying.
Tuesday.
It's on Tuesday.
That makes so annoying that it changed.
Are there requirements? Are there requirements for our question? Or we just have to write a question?
Yeah,
Oh,
let's do like the 3rd. Yeah, let's do the 3rd. And then do we not show up?
Let's do next.
I don't think we really show up at all.
I know, I put a question mark.
I mean, what are we doing?
Your meeting has ended.